Hello, going to be going through this max from common data frames. Your function must return a new pandas data frame with the same data and columns from the first parameter. For common columns in both inputs, you must return the greater value of each cell for that column. You must not modify the original inputs. So in this case, here's our output. So we were given two data frames. It equals A, B, and C. So we're supposed to return the data in columns from the first parameter. So that would be this. And then, but since B and C are in both of them, so B, I want to check if it's larger. So 6 is larger than 2, so it's 6 there, and then 2 is larger than 1, so it's 2 there. C is 2 is greater than 1, so 2, and then 2, and 8.5. So I think I understand. I have these two arguments, two data frames. I want to check if the columns match. If they do, I want to iterate through those columns and see if it's bigger. So they give us these two data frames here, and I'm gonna use those. You need to import pandas as PD. And let's take a look at DFA and DFB. So one thing I thought I caught, they wanted us to, you must not modify the original inputs. So since I don't want to modify the original inputs, I'm going to do df equals dfa dot copy. So this will makes a copy of A. And next thing I want to do is I want to iterate through the values, not through the values, but through the columns. So df dot columns. So print x. So ABC. Now I want to check if this column is in the columns of DFB. So if x in DF B dot columns, print x. So it should just print B and C, which it does. So then now if I now know that B and C are in there, are in both columns, I want to iterate through the rows. So for I in length of the data frame df. So if df, I want to see if B is greater than A, then I want to update A. So if df dot loc of I, so this is going to be the indexes, and then this is going to be the column name, is greater than, and I want to do DFB. So if DFB is greater than DF, and then same row and column, then I want to update df.loc I x is equal to df.b.loc I and x. And integer object is not iterable. Oh, I want range here. So 6, 2, 2, 8.5. I think that's right. 6. So the output 6, 2, 2, 8.5. So that definitely works. The downside of this is that the advantage of using pandas and NumPy is you're using array-based operations, and it should be relatively fast. I'm using a nested for loop in here and looping through each element in the data frame, which is not very fast. So I'm not using any pandas or NumPy operations. And I was kind of thinking about that as I was typing this out, like how can I make this more efficient? And I think I thought of a way with using np.where. I'm going to put this in the same line. So I'm going to make a new data frame and call it df1, and again make a copy. But this time what I want to do is I'm going to use np.where. And what this does is, I don't think I imported NumPy, yeah. The docstring wasn't popping up. Yeah, so you put in a condition and then you specify what to do if that condition is true. So if I want to do exactly what I did, but with B, I just if df A of column B is less than df B of column B, and it's a lot of A's and B's. So if A is less than B in this B column, then I want to make this df B. Otherwise, if A is greater than B, I want it to be A. So it returns 6 and 2, which is what I'd want to return there. So I think I'd be able to get away with only doing one of these for loops now, which is what I want to try. So for x in df1 dot columns, if x in dfb dot columns, then I want to do this. But this time I want to do df1, and it's red, so it doesn't like that. df1 of x is equal to this, but I want to replace all the b's in quotes with x. So that way I'm using that column in my for loop. And let's just see what happens. So I get the same results. Let's see if it's any different time-wise. Hopefully it is, because it's not using a nested for loop. So this took 700 microseconds on average. This took 760 microseconds. So they're both in a blink of an eye, but this is only 2 elements. If this was a data frame that had 100 elements or 1,000 elements, I think it would be much different. And let's test that out, just for fun. So DFA, I'm gonna do this a little bit different. I'm gonna make it a dictionary. Okay, I'm gonna do np.random.normal and size equals 1,000. So it's 1,000 random numbers in A, and B random.normal size equals 1,000. Let's do it with C. np.random.normal size equals 1,000. And then do the same thing with data frame B here. And what were the columns? C, B, D. Since this is pretty repetitive, I am just going to copy and paste it. C, B, D, and E, and DF A dot head. Oh, DFA and DF B dot head. So let's try and run the same thing. So this should work, DFA, DFB, but with a much larger data set. So this one took 300 microseconds roughly. So first it took 760, not microseconds, milliseconds. This time it took 700 milliseconds. Yeah, so see this, now we're starting to see the difference. So 600 microseconds versus 300 milliseconds. So this one is much quicker than this one. So if you can use like array-based operations using NumPy or Pandas, it's going to be faster than using a bunch of nested for loops. And I'd be curious to see like how other people approach this. Return df1. See if this is even right. Oh, I need to do import numpy as np. So cool. And test and submit. And yeah, there's people doing one-liners of this. I'd have to kind of stare at them. But this is the way that I approached it. Almost exactly. But cool. Yeah, so this is how I approached it. Let me know if you have any questions. Thank you.